Okay, now let's take a look at area 3 of the passport to advanced math. Now, area 3, as you can see, deals with linear and nonlinear systems. That means you have one equation that is a linear equation and one that is a nonlinear. Generally, they will give you one. The nonlinear one mostly will be a quadratic equation. So you need to understand how to solve quadratic equations very well. So let's take a look at this example. Here I have y is equal to x squared, and then I have 2y plus 6 is equal to 2 times x plus 3 in parentheses. And they want you to find the solution of the system of equation such that xy is one of the answers given as A, B, C, or D. So here, let's look at the approach. This generally, you don't have a lot of option when it comes to solving this problem. But as a student, if this is a problem that you don't have any clue, you can always play with plug-in as well. So if you want to do plug-in, that means you know for sure if you pick the answer A as 1. And, if you're going to do plug-in, I recommend that you use whole numbers, because if you have to do fraction, then you are in a very bad shape. If you're going to do plug-in, then we are going to assume that if xy is equal to 1, that means potentially x is equal to 1, y is equal to 1. You can assume that. So for now, let's assume if x is equal to 1 in this particular case, if we say x is equal to 1, then we mean that y is also equal to 1. Is that true? Well, you have to test with the equations given to you, and it has to satisfy both of them. So for the first one, we know y is equal to x squared, which is equal to 1 squared, which is equal to 1. And so when x is equal to 1, y is equal to 1. Let's play with that and see if that will also work. When x is equal to 1, then and y is equal to 1, then we're going to have the situation where 2 times 1 plus 6 is equal to 2 times 1 plus 3, which is equal to 2 plus 6 is equal to 2 times 4. And this is 8, and this is also 8. Therefore, if we pick x equal to 1, y is equal to 1, the answer is A. So it works fine, right? That one works fine. So we don't have to do any more work. So if you try and error, then you can just guess, and this is fine. But let's look at another way. The best way to do this, if you are a student of mathematics, is to just solve this as a systems of equations. So one is nonlinear, so it doesn't change the way you solve it. So what we would do is any place in the second equation, let's call this here, this will be our first equation, and this will be our second equation. So we're going to substitute the value of y is equal to x squared in the second equation. That means any place we see y, we put x there. So the second equation becomes 2 times x squared plus 6, and that should be equal to 2 times x plus 3, right? Therefore, this becomes 2x squared plus 6 is equal to 2x plus 6. Let's bring everything together. So 2x squared minus 2x plus 6 minus 6 is equal to 0. What I've done is I move all this. I've subtracted 2x from here, subtract 2x from here, subtract 6 from here, subtract 6 from here. So that gives us 2x squared minus 2x is equal to 0. This cancels out, as you can see. And we can simplify this and say 2x outside, actually, x minus 1 is equal to 0. You can see that? All right. So if this is true, then we can say that 2x is equal to, from here, we can say that 2x is equal to 0, which implies that x is equal to 0. Or we can say x minus 1 is equal to 0, and therefore x is equal to 1. Right? Well, if x is equal to 0, we know they say x has to be greater than 0. Therefore, this cannot be part of us. So we're going to take x equal to 1. So if x is equal to 1, then we can plug into any of the equation like we did in the first. Then from the first equation, then y is equal to x squared, which means y is equal to 1 squared is equal to 1. And therefore, xy is equal to 1 times 1, which is equal to 1. So that gives us, still give us a. So that is how you solve the systems of equation, except that one in this case is a nonlinear and the other one is linear. So we're gonna do more of this, and you see how to solve these kind of problems.